when I run this all the way up to maximum speed, it seems to run perfectly fine. There's the problem right there. Now watch what happens when I turn it all the way up. It actually doesn't start acting up until it dies back down in RPM. If I use the rapid traverse button, very slight wavering of RPMs, but it seems pretty normal. Also, direction of travel doesn't seem to make a difference either. And the fact that when I use the rapid traverse or max speed, it seems to run okay, makes me think it's not a motor issue at all, that it's the controller. So I did an internet search, and I did find a website of a company that does repairs on these, and they said, some of the things you may experience with your servo is, like dead, not working at all, smoking, but one of the things was erratic feed, and that's what this would be, erratic feed. Unfortunately, all they're saying is, hey, you may experience erratic feed, send it to us and pay us money and we'll fix it. Which if I have to do that, I will. But I'm a handy enough guy that if it comes right down to it, I can actually purchase a new board to put inside here. I just wish that I could diagnose and repair the board that's in there. There's not a lot on that thing for electronics.
Well, I'd like to tell you that I was able to troubleshoot this without a schematic down to the component level and determined that this capacitor was bad, so I replaced it and fixed the problem. I don't know if I fixed the problem yet, but the truth of the matter is I did a very unorthodox method of repair, which is just stab in the dark troubleshooting. Barely troubleshooting for that matter. That's where you just take a guess at what component is bad and just sub it out and see if it solves your problem. I looked at this board, I looked at what's on here, diodes, capacitors, resistors, and some semiconductors. Because it works some, I'm leaning towards it not being the semiconductors. So there are some capacitors on here, but there's only one electrolytic capacitor on the whole board. It's this guy right here. It's a 100 microfarad, 16 volt axial lead capacitor. I did not have one of those, so I took a 25 volt, 100 microfarad, so same rating capacitance wise and a heavier working voltage, and look how much smaller it is. And that's because of advances in technology over time. Anyways, electrolytic capacitors are known to go bad with age, so that's why this was a suspect for me to consider. Didn't even bother testing that old one, just decided we're going to just sub in a new one. I also tested these three resistors that are in the area of this cap, and they all measure within the tolerance of what they should be, so we're not dealing with a resistor that opened up some over time and is causing a problem. So we just put this back together and we'll fire it up and see what happens. Alright, here goes nothing.
Same exact thing.
So I decided I wanted to get this potentiometer out of the unit so that I could check and make sure that I don't have something going on wrong with the potentiometer itself. I kind of didn't think that was the case, but just for the heck of it, I figured I'd clean it and see if that made a difference. So I had to take this out to do that. In the process, I learned that to get this out, you go in through this access hole right here, you take this screw out, that allows this whole shaft assembly to disengage and come out. This spring goes on here like this. But here's the interesting thing. This lever right here is what's responsible for engaging and disengaging this dog. And that happens when you flip this lever. So underneath here, you see this mechanism in here. this is the back side of it, but on the opposite side of this that we can't see is basically the cam that this lever rides on and gets pushed up and down by, okay? But what I happened to notice when I was looking in through that hole before I took it apart was that these wires right here that actually lead to the rapid traverse button were pinched in between there. They were literally getting crushed in between this flat metal area right here and that cam. And lo and behold, when I got this all out and I took a look at these wires real closely, this is what I found. So hopefully this is focusing, but you can actually see, like the blue wire right there, that insulation is completely crushed. The yellow wire is crushed to the point that the insulation is actually broken. You can actually see copper wire exposed right there. And I think on the yellow one too. Well, not so much the yellow one. So I know what you're thinking. You're thinking, well, but that just goes to the rapid traverse button. So you would think if this wire broke in here, that would just cause the rapid traverse to not work, and it shouldn't affect the low speed, except for a couple of things. First off is the possibility that maybe when this insulation broke, that this was allowed to short out to that metal piece. That could be a short. Secondly, turns out, instead of just having two wires go up to the rapid traverse button, which when the switch closes makes it rapid traverse, there are 4 wires. And the way that it's wired, you'll notice that there's 2 wires go to these 2 pins, but on the other side, the 2 wires go to the other 2 pins. And this is a dual throw switch. In other words, this has 2 sets of contacts in it and double pole. So this is a double pole, double throw switch. In other words, from the center pin to one pin is shorted when the switch is not being pressed. And when you press the switch, those 2 connections open and the other pin to the center pin shorts out. And that happens simultaneously for the other side. So essentially what's happening here is when the rapid traverse button is not being pushed, 2 of these wires are shorted together. When you press the rapid traverse, those 2 wires will open and the other 2 wires will short together. So that would explain how, if one of these wires is shorting out or broken, could explain why this is erratic. So I already removed 2 little wire ties that were on here. So what I'm going to do is I'm going to cut back to where the wires do not appear to have any damage. Actually, it looks like there might be a spot there that's crushed too. Interesting. All right. Oh, something already is kind of rotten in Denmark here. This switch, got my continuity tester on the beep mode, so I don't have to look at the meter. But this switch is marked with a NO and an NC, which is normally open, normally closed. So it is a dual throw switch, like I suspected, which means that this center pin should be common, and one of these 2 pins should have continuity to the center pin. And then when I press the switch, that continuity should go away and the other pin should have continuity to the center. Something doesn't seem kosher with that switch. I think I may have blocked the view here, but essentially I'm getting some weird readings on this switch. I think what I'm going to do is I'm going to unsolder these wires. But before I do that, I will make myself a diagram. Alright, this switch is clearly marked on the side, Alco MPG 206R, and that is a switch made by TE Connectivity. It's still widely available. It's actually a pretty expensive little push button switch. It's rated for 6 amps, and replacement cost is about $25 to $30. The catalog online confirms that it is a double pole, double throw switch, momentary contact. So there's something definitely really wrong with this switch. So I figure before I go wasting any money on buying one of those switches, I'll try testing it and just simulate the switch by shorting wires together. So I cut back the damaged wiring and spliced in some new wire, extra long, and then I use some heat shrink tubing. So what I'll do is I'll put this back together and I'll run these wires out the hole on the side, and I will use my little diagram to simulate which wires I short together to simulate which effect, whether the switch is being pushed or not, and test run it. Alright, I've got this back together enough so I can do some testing. So my diagram shows that the normally open connections were green and yellow. So that means that when you press the button, green and yellow would short against each other. So that's green and yellow shorted to each other is rapid traverse. And then when you release the button, green and yellow would open and blue and orange short together. So the normal state when the button's not being pressed, blue is shorted to orange. So I've got my jumper wire on the blue to orange, and I want to make sure I don't touch the case. I don't want anything to short out. I've got the switch in the middle position. Let me turn the potentiometer. Well, let's turn it about halfway. I don't have that middle shaft in place, but I don't need that to run the motor. Does the same exact thing. So much for my brilliant idea that it was just a bad switch. Glad I didn't waste my money on that switch. Alright, I'm calling it. Time of death, whatever time it is now.
Here's the spare one of these Wells units that I had. Came with the milling machine I bought for parts. So this one's got a circuit breaker right here where I thought that was a fuse holder. So I wonder if that was originally a circuit breaker on the other one too. Oh, that's the toggle switch that's on mine. It's busted off. Huh. This is the light, just like on mine. It's completely broken. Knob is broken off, but this unit seems to work. Sounds horrible inside though. So I think this unit was stored outside. The entire milling machine I think was sitting outside under a tarp or something. And condensation or water, rainwater or something got to it. Took this bottom plastic cover off. This is interesting, they had this tape on there to help keep this from falling off. This is all rust. It's all rusty. So that's where all that horrible noise is probably coming from right there. We'll open it up and see what it looks like inside.
Well, it seems pretty clear to me where a lot of this bad noise is coming from. This bearing on the bottom here, which I can see rust on, sounds downright crunchy when I rotate it by hand. The top one is not as bad, but it's not as good as the ones on the other unit. Alright, so what I ended up doing was I ended up taking the commutator assembly out of the other unit that had good bearings on it and just swapping it out for this one rather than waiting for an order of bearings to come in. Then I also swapped out this gear mainly because I noticed that the wear pattern, I figured the wear pattern on the other gear might not be the same. I ended up scraping out the hardened gunk that was in the in between the teeth and lubing it up. There's some noise there, and what that is, that pulsing noise. The gear appears to be going like this a little bit, and it appears that the problem is that the end of the shaft has a slight bend in it. I noticed that my other unit, when I had it on the mill and it was working, also kind of exhibited the same kind of noise, so I'm not sure exactly what's going on with that. I lubricated the pinion bearing that this shaft that goes up to here runs through, and I also replaced this switch, the toggle switch that was broken off on this unit. I lucked out there. This is the original switch. You can see it's a low profile switch with the wires coming out the side. It's a 3 amp switch. This one is made in Mexico. I really lucked out because I have a few of these switches left. I got these a long time ago. I don't even remember where they came from or what they were used for. They had these little plastic covers for mounting on something, I don't know what. But what these are they're nice little Leviton switches. They're low profile just like this, and they're 3 amp, the same rating as these. The only thing I didn't like about this switch, as opposed to the original one that was on here, is they have very short little toggles. But that should be okay. Certainly better than just having a broken switch. I didn't replace the brushes on this one because the brushes, when I compared them to the new ones, they had almost the same amount of meat on them, so I would say these brushes probably weren't that old. Well, I guess I'm going to call this repair good enough. So I think now I'll mount this back on the machine and see how it runs. When I went to put this together, I used the original gear that I had taken off of here, the bevel gear. And when I put it in this housing, it sounded horrible. And what I realized was going on, when I compared the two side by side, they made a change in the thickness of the gear. So this gear doesn't mesh well with this unit. So I've got to keep this one with that unit. So the good news is it's working. That weird noise that's always been there ever since I've had the machine, even with the other unit on here when it was working correctly. So I don't think much of that. So I determined that that noise is due to the fact that the shaft that has the little bevel gear on it, it has a slight bend to it, I guess. So it's out of round. So what's happening is that bevel gear is meshing more and then less as it rotates. So now I've got a working feed, only now I've got this problem. When I hit the rapid traverse button now, see it did it for a second and just stops? I have no idea why, but my rapid traverse on this unit stopped working. Pulsate, it works. There we go. Well, now it's working, so maybe that button's not so kosher, I don't know.